Okay. Well, we will be having the learning talks. We have 10 submitted talks. Each talk should be more or less 5 minutes. We can have more than that because there are a lot of talks. Well, our first talk. Thanks. Our first talk is from Gastón Destay. Then we have Martín Díaz. Then Boris. Then Mark. Also, Facu and I will be giving a tech talk about quiz. Also, we have another for Seth Berman, Ludat, Mariano Martinez, and also Ronnie Salgado. So, please, if you can be close to the stage, so we can have the talks as quick as we can. So, please be close here. Could we came here to start the talks? Yeah. Okay. Yeah, please came here. Yeah. So I will put a timer. I will set a timer. So every 5 minutes we will start clapping, so we can have the place to the next speaker. Okay. So that's the.
Bueno, yo soy Gastón Ezequiel Testay, soy desarrollador en Tempines y les vengo a traer mi proyecto final para recibirme en la Universidad Nacional de Quilmes. A ver. Ahí está. Bueno, ¿qué es COP? Básicamente es una herramienta que desarrollamos con mi compañero Martín González, que no pudo venir, que la idea es para que los nuevos desarrolladores que vienen a probar el mundo de objetos y Smalltalk vayan aprendiendo de los errores, básicamente de heurísticas que nosotros encontramos del código, básicamente. Esto es todo para hablar, así que lo que les quiero mostrar es esto. Bueno, ¿se ve bien? Excelente. ¿Qué fue lo que desarrollamos? Bueno, algo más o menos parecido a lo que había hablado Facundo en la charla que dio hace unos días. ¿La idea cuál es? Nosotros tenemos un analizador que va chequeando sobre cosas que nosotros, por ejemplo, fuimos encontrando cuando íbamos revisando parciales, por ejemplo. Este es un clásico caso del famoso miedo al booleano, en el que tenés una expresión booleana acá y estás devolviendo otro booleano con un if. Es como, bueno, la idea es que lo puedas reemplazar. Ya te digo. Pará, puedo hacer otra cosa. ¿Sí? No lo suelo hacer esto. Ahí va. Otra cosa, por ejemplo, otra heurística que encontramos fue, por ejemplo, cuando a una colección se le manda el mensaje size igual a 0. Y en realidad esto se podría reemplazar utilizando un isenti. Entonces, la idea es esa generalmente, ir encontrando heurísticas para decirle a los alumnos, che, pueden utilizar, conocer un poco más el ambiente y de ahí ir aprendiendo mucho más, digamos. Otras cosas que pueden llegar a ocurrir, por ejemplo, esto lo dejé, es, yo tengo un test sin assert y bueno, ¿cómo lo arreglamos? Pongamos un assert. Acá, ¿qué quisiera hacer? Bueno, un ejemplito súper corto. Y digamos que se va arreglando, te va dando feedback de inmediato la herramienta. Acá otra cosa curiosa, por ejemplo, lo que está pasando es que se le está dando un mensaje de instancia a la clase y nada, la forma más fácil de solucionarlo es instanciar el objeto y mandarle después el mensaje. Entonces uno va más o menos aprendiendo el entorno. Te va guiando, uno puede clicar en ver y le dice, che, se está mandando un mensaje de instancia a una clase. Entonces, al highlightearse el código, uno ve dónde está el error y lo puede ir mejorando. Eso fue, bueno, básicamente el proyecto con el que estoy para recibirme en la facultad. Sí. Muchas gracias.
Hello, my name is Martín Díaz. I will talk you about, I will try to do this very fast, but I am not usually especially fast when I talk. But this is a work that we sent to an important conference First, briefly, well, I am doing a postdoc in Universidad de Chile right now, and I will do something else in next year, but I don't know what. So the problem we tackled is nowadays there are a lot of JavaScript systems, web pages that will need maintenance in the future, for sure. And usually developers use development the IDE to understand code. So as the most used apparently in statistics IDE for JavaScript is the Visual Studio Code. We looked how this works. It has, as it's usual in many tools, to have I think in red there, the file tree where you have a lot of JS files, and when you select one, you have a master detail schema, and also in this case you have an outline by default of the file that is selected. And we had the hypothesis that if we extend this kind of tools with visualizations, we can have a big impact on how to understand code. So we have, in concrete, we have this tool that implemented Diego, and I helped it in Chile. It was his magister, like his master. It is implemented in Russell, and it uses Esprimo, which is a JavaScript library. You can find it in this URL. So, for example, the outline of the structure of the selected file, we tried with this tree map, which allows you to navigate in the code more visually than the other that was a text tree. In JavaScript, what we wanted to represent visually, especially like the core of this tool, is that you have the files, and the files depend on other files usually, and it can be trivial or not. It can be hard to understand how they are related, the files. So well, we have the files. When a file is selected with a click, you have the different colors for the ongoing and incoming dependencies, and then we choose to give different colors to the folders of the structure with the rationale that usually it has some meaning when the files are in some folder, so it has some meaning to have the same color. No, then the size of the nodes represents the size of the lines of code of the JavaScript. So for dependencies in JavaScript, you have usually this require sentence where you can require a file that is in the same file system in the project, so it's internal, or you can have also a reference to an external dependency. And we also have another notation, graphical notation for the unresolved dependency, because it happens also since we do a static analysis of the file, and sometimes we cannot know what is the reference. Okay, so I show only a bit more, and these are the colors. This is the tool. You can select and navigate the files, but this is the tool opening. You can drag and drop a JavaScript project, and well, here you can see these are files that have tests, and the arrow goes to the entity or the function that is being tested. So there are some patterns that you can discover visually. You have this kind of also the search to look. So, well, thank you. So, and Alexander wanted to transmit this message. So
this is 2 talks. Really, what you see here is Jan Vrani's STX JV branch, Smalltalk running on the RISC-V board. So as you can see, this is actually, to this day, this is the one Smalltalk IDE that is actually usable in for debugging, for developing Smalltalk code that actually works as a Smalltalk system. It is extremely unfortunate that Jan is not here this week to show all of this. And what I'm showing on top of this right now is a very simple automatic theorem proving system, which is completely in Smalltalk. As our friend Tudor Girba says, if you are not running everything completely inside Smalltalk, then you're doing something really wrong. So we have been dependent on external theorem provers for proving correctness of the VM for a very long while, and I decided that this has to change. The other thing that motivated me is the fact that in the last 10 years, this has been a very standard tool for developers of new programming languages, and we are really lagging behind. So this is also an educational, or this is actually primarily an educational tool, so people can understand how proof theory works and how automatic theorem provers work on a Dynabook, essentially. So we give it a theorem that from not A always follows A with no premises, and this is just a Unicode string, and this sequence, this is a Gensen style natural deduction sequence. So that from string just uses petit parser to parse that Unicode string, and we get a Gensen sequence, and then we make a proof tree node of that, and we proof valid, and then I open it, in this test I open an inspector to see the proof tree, so it gives you something that looks like this. This is running, and at this point this is gonna take a little bit of time because this is the first time that it's compiling the code, and if we are lucky, we have an inspector on that proof tree node, and uses LaTeX to actually render this, but it's kind of pretty. So you can actually have the proof tree in standard mathematical notation. So you can study this thing on a Dynabook, and you know, I can take a bigger thing. This ABCDE thing is a bunch of this, and we're proving E, and that's your actual Gensen proof tree. I can make this bigger, or I can scroll this. So this is what I wanted to show. Can I make this bigger? Just manipulating the mouse, whatever. So this is the 2 messages I wanted to give.
Hi, my name is Mark Gonzalez. It's okay. I work for a company called Labware. People from Labware have been here time and time again over the number of years. This is my first trip here, so I'm very happy to be here. A colleague of mine, Jake, is also here for the first time. He's waving his hands, but of course, many of you know the other names that are here, including Boris, who just showed us some stuff. Now before I continue with this very, very short presentation, I thought I'd show you something pretty cool. So hopefully that I can do this now. That's my, see, I'm going to cycle over until I ignore my email, you know what? Let's just do this. There. Okay, so I'm going to log in. And when I do so, it's going to do a round trip to a server that I have in Europe. So it's going to take a little while. So the image is quite small, but just ignore that for now. Going to go to the server. It's going to pick up a list of what we call tasks. And when that's all done, it's going to present the tasks on the screen that you see here. So these are configured tasks. These are not hard-coded into the app. These are all being driven by data that's on the server. And I can do various operations. I won't take you through all of them. But for example, I'll just choose here to perform a little view of an active sample. After a minute or so, after a couple of seconds, it came up. That's not too bad because, again, it's doing a round trip, getting data from the database in the server and showing it back. If I'll do that one more time, it'll take about the same amount of time. No surprise there, pretty fast. But if I now swipe over and I do the same thing, it's instantaneous. And the reason for that is because it's a multitasking solution. It's able to keep various tasks running in state. It doesn't require to abandon a task and then have to reload it all over again. So even though I only see one screen, there's actually many screens that are running simultaneously. Something.
In what language is that written in?
And the language that all of this is written in that you've just seen now is Smalltalk. The code that's behind it, some of the code that's there is decades old, still doing its job. Very recognizable to our users that are familiar with the desktop versions of exactly the same program. So it's a tremendous technical accomplishment utilizing a well-established, mature environment.
We have our own compiler program.
I'm going to log out of the application there so I don't freak it out, and I'll go over back to PowerPoint. Not Spotify. Oh, we can go to Spotify if anybody wants. Facebook? Okay. So a couple more slides. I think I have another couple of minutes. Very quickly, just about us. We are a software developer. We make software for use in companies and industries. You can see various examples of customers that use us. We have thousands of customers, about 2,000 or more customers in 130 different countries around the world. Some of these are global sites that are using it across different countries, multilingual, et cetera. Very large-scale enterprise solution. Also utilized a lot in the regulated industries, pharmaceuticals, food companies, et cetera. And these people pay a lot of attention to the IT aspect of the solution. The key thing is that we've been using Smalltalk since day one. Virtually all of our code is Smalltalk. We have a very small amount of things written in other things, but virtually everything, and certainly everything that drives the application, is based on Smalltalk code from day one. And all of that code is still in play, even though we've done the usual thing of going from desktops to browsers and now onto devices. So why are we telling you all about this? Here we go. Is we have an ongoing mission. Part of our mission is to remain in business and sell more of our types of software. But an ever-increasing part of our mission is to promote Smalltalk within the sort of enterprise world. We want to make it the language of choice for companies. We want to make it feel as a modern language and to do all the things that everyone in this room knows it can do. Part of that's going to come out of also ensuring that we can strengthen ties with the various different communities that exist. I mean, we're here in Argentina. I love the quote the other day, yet another Argentinian guy. I think that was yourself or somebody? But we need to do the same kinds of things in other countries around the world and get everyone networked together. So I'd love to hear from anybody that has great ideas on how to do this. We have some thoughts about it as well. Part of what we're doing also into the future is we're going to be providing an open source set of solutions for the entire stack that's based on the Smalltalk ideology and the Smalltalk solution. So please, if you have any ideas, please contact me. There's the email address. I guess this presentation will be included with all the other materials anyway. And for those of you who prefer to write in Spanish, please, you can write in any language you wish. I'll put it through Google Translate. But if you do it in Spanish, I'll just do it in my head instead. Okay? Thank you very much.
Okay. Well, we want to talk to you about some job that we were doing on quiz. We were with Facu. We were rethinking the release workflow and how to improve the development of the core of quiz. So the first thing that we did with Facu and some help from Ludat and Nico, and some work in progress that we realized some Juan and Julian from Mercap were doing is to integrate quiz with Travis CI. It was a little hard because quiz does not support Monticello like Faro or Squeak, and we have to integrate with the current version system that quiz supports. Now we are running all the base image tests, and currently we are building and running all the tests for Linux and Mac OS, both in 64 bits. You can see the latest build there. It takes like 1 minute to run all the tests on the base system. And the output of the entire run is like that. We have some colors and some ticks and emojis and those things.
Yeah, it's more difficult than it looks to make that text appear green and with a check mark. So, yeah. And so next, so what's next, right? So some next steps that of work that we're thinking to do is related to, first, we want to check the compatibility of packages while we run CI. And that will include running the tests of the standard quiz packages, which are already included in the repo, and also to run the test on popular packages that are maintained by the community to ensure that we don't break the compatibility with updates that we do on the base image on the system. Another thing that we will be working on is to generate automatically one-click releases with everything that you need to be able to run quiz without like doing anything else. Also, it will be very nice to start working on moving packages out of the image, so we can start using PRs to modify the code, because as the packages are outside of the image, then we can use all of the text-based tools that we have on GitHub. Also, another thing that we'll be working on is to automatically generate and publish documentation that we have inside the repo or on the image, and the idea is that we can make that documentation available on the net automatically as part of the CI runs when we create a new release. And lastly, it would be very nice, like this is a future work, but to be able to bootstrap the image so that that will enable us to be able to develop in like using other workflows that we aren't able to use because we don't bootstrap the image. So yeah, those are some next steps. So if any of you already solved any problems like this for your Smalltalk distribution or have any suggestion, feel free to contact us. So yeah, I think that's it. Thanks.
Okay, so this one, this is really I wanted to give some recognition to one of our interns, yes, I think so. Okay, so this is we had an intern who, he was completely new to Smalltalk. He had never worked with Smalltalk at all. He's a sophomore in the university. His name is Lee Clayberg. He's the son of one of the owners of Instantiations, which is Eric Clayberg. And we started, I literally started with some training material, and I just want to show you the progression of, because sometimes we get arguments like, I can't find any Smalltalkers, which I think is a really stupid argument, but that's why I'm not the one who should tell them, because I let the marketing guys tell them, otherwise it'll come out exactly like that. But I think that, I've been told by customers that if you're willing to invest 3 months for proficiency, 6 months for idiomatic proficiency is what we've seen. If you're a company that's willing to invest that, then you can find people. So it's not a good argument. And so this is proof. We've got a guy that, he's in college, and I'm going to show you the progression of what he built. And it got to the point where many of us just looked at each other and were like, I couldn't build this. So it was pretty impressive what he was able to do. So we'll just go through each one of these. So the very first part, it's just your basic calculator app, and you could think, no resizing, anything like that, but it works, it's functional, and he was able to build that using VA Tech, and that was pretty nice. So then next up, he started messing around with kind of the lower level graphics stuff, and he was able to put together some nice little towers of Hanoi, which he was doing some sort of class in his college for, so he implemented that recursive algorithm and then made the graphics primitives for that. So at this point, we're like, thinking that's really cool. Good job, you're really picking this stuff up fast. And then next, he, somewhere around, then we have, Snake, which I'm going to be bad at it, but he really created, he did this whole thing, and this ended up, they started to get to the point where, I'm at work and I'm thinking, these are kind of fun actually, I can take a quick break. So, this kind of stuff, so I was thinking, very good, he did a really great job. And so then things continued. He modeled remember Minesweeper from the old Windows? He did a perfect recreation of that. And it was, it was like impressive. It was like, wow. So at this point, I'm thinking, man, this is where we're starting to look at each other, thinking, this is getting really good. So there's Mastermind. He did. I'm not very good with this, knowing how to play it, but for those of you that do know, it's fully functional, but I'm not going to show that one. He did Battleship. So this one ended up being kind of fun. Let's see. I don't know. Well, I won't show this one, but that one's cool. This one was one of my favorites because I loved this growing up as a kid, which was the Tron light cycles. So this was. So I'm the blue guy. So I don't know if you guys remember the Tron games, but this ended up being a lot of fun. So, and he built some sort of AI for this too, so the two can play each other and make good decisions and things. Not like I just made there, but and then my favorite. Okay, so this is the final one. He built Pac-Man, and this is a faithful recreation of Pac-Man. This is the algorithms that were used for Inky, Blinky, Winky, and whoever else, the ghosts. And it's just a fantastic game. This is it just did a really good job. And the ghost algorithms are the algorithms. Everybody acts the way that they're supposed to act. And he even described to me, the way that everybody's acting and the exact algorithms and all that kind of stuff. So, he recreated it exactly. So this was his summer internship. Yeah, about 3 months. So, right? Yeah, he's a sophomore in college. He's still, and yeah. Well, we still have him. So sorry, you'll have to wait. So anyway, that was his work. So thank you.
Okay. Everything is small, but it's okay. All right. So what I'm going to talk about really quick, it's about well, let's speak in English. Last week, about 2 weeks ago, a couple of friends of mine, Facu and Gaston, told me, hey, we're going to spend the weekend at Neuquén. Do you want to come with us? And I said, yeah, sure. And they told me that before that there was the small talks, and I said, I could go there because, well, I'm traveling, and why not? And so I thought I should do something because I don't like traveling and doing nothing. So I set out to write a Smalltalk VM using Haskell for reasons. Why not? Right? And so the first thing I thought was a couple of hard things. I did a couple of 1 or 2 VMs before, but it was Smalltalk, and I don't have that much experience with Smalltalk, So I started thinking of some hard things that I didn't do before. For example, implementing foreclosures, which I didn't know how to do, showing actual UIs because my VMs only run on the console, having primitives that did stuff because I knew Smalltalk had those, and showing a debugger, which I had no idea how to do. And yeah, those things one would think that were really hard, but I got a note because I spent most of the time trying to read the image, because the image format for at least for images for the code VM it's not documented anywhere. I mean, it's documented in the actual code, but that doesn't really help. So yeah, I spent like 2 weeks trying to read the Smalltalk. I read the Graal VM implementation, and read the Squeak.js implementation, with which Squeak.js reads a different kind of image, which is not compatible with Graal, and not compatible with some versions of the thing that the code VM reads. So yeah, and I'm going to talk about the things I actually did, which is this beautiful number, which I'm guessing most of you recognize, which are for code at least, they are the special numbers, they are magic numbers which define which versions and which features the image needs to run. It makes a lot of sense, but different versions are not compatible with each other, even in the layout of the object, so there is no way to run a version with a different number with the same VM. That's impossible. And something I also found that was very, very weird was that I couldn't find in the source code when did it parse the object. Like I'm seeing I know there is a immediate pointer for small integers, but they are not getting parsed before running the image. So which is very weird, because I imagine there has to be something different in RAM when the image is actually run, and the answer is no. The image is read as is from the file to memory, and after that things are accessed by offset, which I guess is okay, but it makes the code for reading the actual pointers, which are many kind of pointers, sparse, and everything that has to read a different pointer is implemented somewhere else where the primitive needs that pointer. Also, there is a special object array, because the image is a flat list of a lot of objects, and some of those objects are special, and there's nowhere to be seen that those objects are actually special. So after a while, I understood that there is in the header file, in the header of the image, there is one of the numbers that appears there is a special objects array, which has a list. It's technically it's an object which has as fields all the other objects that are special for running the image. For example, nil is the first field in that object. True, false, the old executing context, the float class, the small integer class, and many more. I think on the Graal VM there are like 50 special objects, and most of them are not used. Sorry. Well, what I did got to implement was a thing that reads the image and tells me how many objects there are. In this quiz image, there are 94,327 objects, just so you know, and I can print all the objects. Yeah, that's the raw image that's reading things, and yeah, I'm out of time.
Hello. Well, hello you again. I promise you the last time I will be on the stage. You won't need to see me again. So this time it's something very cool because it's local from Argentina that we did with Gerardo Richarte, Richie, como le quieran llamar. Sorry. So basically there is a big, huge event that happens once a year in Argentina, which is called La Fiesta Nacional de la Flor. which is a big event where a lot of people goes there. Many years ago, they built that big bell tower, which has 18 pneumatic bells. And what they did is to buy this special hardware, which was made especially for them. It used to have a peak processor with only one song stored on an EPROM, which was Yesterday from the Beatles, and that's all what the thing could do. So that thing you see there, that's the whole thing, that's the whole hardware, which is somewhere below the bell tower. You can see there is a Raspberry Pi. So Gerardo, 2 years ago, I think it's 2 years ago, removed the peak processor, put a Raspberry, make some magic, and then he was able to play a MIDI song with Python on the bells. So then I joined this year in the project, and we did a web interface which allows you to pick whatever MIDI songs, and we interpret the MIDI songs for each MIDI event. We associate the note to a bell, and so we can play MIDI songs on the bell tower, like if it would be a piano. So the architecture I already said, it's 18 bells tower. It is run with one Raspberry Pi Zero, 2 HUDs, because we needed more GPIOs than what it brings, and also because we needed 5 volts. And the web app that we ran with BA Smalltalk, and the same for the GPIOs. Everything we did it with BAST, with open source licenses. So let me show you a quick demo, which I'm not sure if it will work, but okay? I will try. So this is the web app, which is mobile friendly. So on the real event, they use it from the mobile, but I will run it from here. And I will try to play a song, which is Nothing Else Matters from Metallica. And can you see the LEDs? So this is my test. I cannot bring the bell tower to my home. So this is a piano made out of LEDs where the order of the note matches exactly to the bell tower. So by doing this, I can assure that everything from our side is correct. The MIDI interpretation and the connection to the GPIO. So that way I can test. So you need to imagine that we are playing Nothing Else Matters here. So this is my way of testing the project. Here you can see, once we were able to run here, the next step was to run on the real hardware. So you can see Richie there, and you see the lights turning on and off. That means that we were able to really turn on and turn off on the real hardware, okay? And you can see they are playing from the mobile. So once that worked, the last step was to check if it worked on the real hardware, on the real bells. And so here it is. I need volume here. I know. I think this is from the Beatles, if I remember correctly. There are certain things you cannot put notes too frequent, because the hammer and the pulp cannot do like 5 notes in a second. But anyway, that's the thing running for real. And I know it is starting. Finally, all I wanted to show is that because Serge showed that yesterday we won the 3rd place at ISU Technology Awards, and with some of the money we sponsor some NVIDIA JSON for him, and just wanted to add Gerardo, which wasn't on the original slide. That's it for that one. And I'm sorry, but I have another one next to this one. So this other talk, I presented this at ISU at the very last day of the conference. I titled it Using 128 GPU cores, TensorFlow, and BS Smalltalk to detect coach bias with the ISU 19 hashtag from Twitter. So that's exactly what I did. I mean, I have NVIDIA JSON Nano, which is here, which is complaining to connect. I don't know why. And this machine has 128 CUDA cores, and obviously we were able to run BA there. It's ARM 64 bits. It has an Ubuntu Tegra, which is a Linux made by NVIDIA for this. So you can see some of the pictures that I grabbed from Twitter. I didn't want to grab pictures from people that didn't have the authorization, but here it's some more. So at the end I say thank you for training these TensorFlow models, and I think I won't be able to show because it doesn't want to connect. It's blue, right? Yeah. So, I don't know. Sí, pero va a tardar unos segunditos, no sé si tengo tiempo. Me fijo. In any case, what I was going to show is Bast calling TensorFlow and doing image recognition to one of those pictures. The results, yeah, I don't have the results, okay. But I can show you some example of what would have been the result. It's basically an image with the square of what was recognized in the original demo. It was a picture with us recognizing the bears. Here you can see two different models. So one is much more accurate. The one on the right is much more accurate than the model on the left, but it takes more time, the most accurate. Here you can see some other pictures. We are rendering this from within Bast, so we are calling TensorFlow, and then we open that on Bast and we make the squares and the labels and so on. I think that's it. Probably it doesn't want to connect. Yeah, it won't connect. So, I don't know. Okay, that's it.
Hello, I'm Ronnie Salgado. This is going to be a short demo. This is the Crank VM, a really simplistic experimental prototype for a VM, a Blue Book style VM context-based with the laziest garbage collection algorithm, no garbage collection at all, just leak all of the memory. And this is purely written in C. And like a previous talk, I did this because I also wanted to document myself on how the image format works. But I can pass a normal Pharo 7 image, 64 bits image. I start executing the main process, running some bytecodes. It eventually reaches into a primitive fail because most of the primitives are not implemented. Then it will start raising some exception, and then it will be fail again in another primitive fail, and it will be and it ends in a infinite loop. But what is interesting is that I can modify the special objects array to insert a global variable into a reference to a global in the end, where I can install a block that will be executed by this VM. I can write the image. And then I can execute that block and return the final value. Like that, I can isolate some bytecodes and start experimenting with different bytecodes. So this is implemented completely in C. It uses the Sport Object Model. I had to read a lot of the CockVM source code in order to implement this. And I'm also exploiting a lot the layout of how C structure works in order to reference to the objects. Here we have the code of the interpreter. It's like all of that code only for implementing all of the SQL V1 plus closure bytecodes. All of the bytecodes are implemented. The hard part is on implementing the primitives themselves. Well, that's how much. So that's how much the debug version of the VM weighs, less than 1 megabyte. It compiles really fast, and it's only 128.5 kilobytes. That experimental VM. There's no garbage collector, so getting into something that can be actually useful, it should be like twice that or maybe triple of that. So thank you. This was a really short demo.
Bueno, hola a todos. Mi nombre es Pablo Kogan. Voy a dar la charla en español. Vamos a hablar sobre un proyecto que se llama Hornero. Es un desarrollo de la Facultad acá de Informática de la Universidad del Comahue y es un gestor de torneos de programación, digamos un manager de Programming Tournament. El desarrollo arranca en 2014, la universidad fue sede del TAP, del Torneo Argentino de Programación, y se presentaron dos problemas a mi criterio sobre el torneo, el TAP. El TAP hereda las reglas de la SM y solo se permite programar en Java, C++ y C, y aparte los ejercicios son muy complejos. Entonces dijimos, bueno, vamos a desarrollar un gestor de torneos de programación en donde tenga dos premisas. Se pueda programar en cualquier lenguaje y sea para cualquier nivel de programación, entonces que los ejercicios sean desde más simples a más complejos. Bueno, a partir del 2014 hasta ahora hemos desarrollado torneos de programación en escuelas de nivel medio. Todos los años tenemos cerca de 200 chicos de más de 10 escuelas que participan entre cuartos y quintos años, y los chicos programan en el lenguaje que les enseñan en la escuela. Hay algunos que programan con PCInt, que es un IDE en pseudocódigo, otros en Java, en Python, en Smalltalk no tenemos. Bueno, el sitio está público, es hornero.fi.uncoma.edu.ar y lo que permite es gestionar esta comunicación con la resolución de los problemas. La dinámica que planteamos a los chicos es primero resuelven en papel, para enseñarles la abstracción del problema, después eligen el lenguaje que van a usar. Y bueno, nos faltaba la comunicación con Smalltalk, conocimos ahí a los chicos y los chicos desarrollaron el stub para que Smalltalk hable con el hornero. La ejecución siempre es el cliente y se comunican vía una API REST. Y bueno, ahí...
¿Vamos con
Sí, sí.
Perfecto. Bueno, está bien. Lo que armamos es sencillamente una herramientita que... Ah, perdón. A ver, pongamos... Más grande
Mientras el desarrollo de hornero, yo soy desarrollador PHP, no me peguen. Es un desarrollo en PHP sobre un framework que se llama G. El desarrollo fue hace 5 años y como funcionó y viene funcionando bien, se ha modificado muy poquito. Bueno, entonces lo que desarrollaron los chicos, bueno, explica.
Bueno, lo que provee Hornero es una identificación por token. Ahora vamos a entrar a la sesión de Fran. Nos da un token.
Agranda un poquito la imagen. Ese es el home del torneo, hay una cuenta regresiva, les muestra los enunciados de los ejercicios y bueno, y eso del token identifica al usuario. Sí. Entonces ellos van a copiar el token.
Bueno, tenemos un token. Nosotros podemos ver los ejercicios que tendríamos para resolver. En este caso vamos a hacer el más sencillo, que es la suma de dos números, simplemente para mostrarlo un poco. Entonces decimos qué ejercicio vamos a estar resolviendo. La herramienta, cuando nos provee los parámetros que nos envía Hornero a través de self-arguments, si los quisiéramos, entonces en este caso sería pedir los argumentos, el primero, que como lo recibe a través de una API es un string, así que lo queremos transformar en un número, más el segundo, y esto lo que hace es hacer una request directamente al server con el token para poder enviar la respuesta. ¿Sí? Acá nos avisa que enviamos una respuesta correcta. O sea, para obtener puntos en realidad en el juego hay que enviar varias. Acá en la tercera nos avisa que lo respondimos correctamente y por ende tuvimos un punto. Y si volvemos aquí y lo recargamos, tenemos las 3 respuestas correctas que enviamos, que se generaron en base al algoritmo que ingresan los alumnos, escrito en smalltalk en este caso.
Y si volvés al home del torneo, bueno, ahí le sumo un punto al anda atrás. Bueno, ahí Francisco tiene un punto. Bueno, el torneo está abierto y pueden jugar. Ahí está el staff de Smalltalk, está abierto, hay 5 horas, así que si quieren, bueno, sí. Muchas gracias.